presenter is Dr. Muhammad Ridwan Mansor. Dr. Ridwan Mansor. So, he started his career at UTeM Communication in 2005, and he completed his PhD from University Putra Malaysia. So he has a certified TRIZ level 1 as instructor and also certified TRIZ level 3 as a practitioner. So next presenter, Dr. Muhammad Rinatash Rozaman, he complete his first degree in University Technology Malaysia and pursue his PhD and got his PhD also at University Putra Malaysia. So he is a certified TRIZ level 1 instructor and also certified TRIZ level 2 practitioner. So that's brief introduction for our speaker today. So without further ado, so I would like to invite our first speaker, Dr. Muhammad Rizal Mansor. Okay, this webinar is for you. Okay, Dr. Rizal Mansor, you may begin the talk now.
Thank you very much. Yeah. Thank you very much, Dr. Muhammad Rodi, for the welcoming speech and moderating the session for this evening. So thank you very much as well for the an opportunity given by CARE, okay, for us, the TRIZ practitioner in UTeM, to share a little bit about theory of inventive problem-solving method and how it can be applied, especially for problem-solving situation. Okay, so let me begin. Okay, first and foremost, I would like to introduce that to all the participants. We have eventually and successfully formed a collaborative team comprising of several UTeM staff with in this problem-solving method. Okay, so at the present moment, the team comprises of 6 members. Okay, myself, Dr. Mai, Dr. Zaid, Mrs. Isadora, Dr. Adinata, and Dr. Muhammad Ali. So, and we hope that in time to come, we could have more sharing session to all of the participants, and this is wonderful knowledge to all. So the webinar content for the evening, we are trying to give a brief introduction, compact and brief introduction on what is TRIZ and how it can be very useful for problem-solving method, and could be a good complementary to similar problem-solving process to complement other problem-solving methods currently exist. Okay. So let us start. So the training content is a standard. The content shared for this evening is a standard content, okay, delivered to all certified TRIZ level 1 practitioner by the Malaysian TRIZ Association. So we have the privilege to share the content to all of you. So start first with the typical innovation process. So as we know, the typical innovation process started with the problem to solve, And in order to obtain the solution, okay, we apply various methods of innovation process, such as thinking out of the box, brainstorming, okay, collaborative discussion, etc. So as we know, in a typical new product development process, we started with so many raw ideas, okay, and as the process develops, eventually from that so many ideas, most probably one or two ideas will be successfully launched to the market. So information driven, so it requires quite some effort to deliver one product to success. And what we would like to introduce is there any other method that we could reduce the amount of work, but in the same time, most probably 100% rate of success to the market? Are we able to do that? And if yes, how could we do that? Then come to TRIZ. So this is where TRIZ come in, okay, as part of the solution. TRIZ is basically a acronym, okay, translated to English, term as Theory of Inventive Problem Solving. So it is a systematic problem solving method based on logic and data. It was developed by founder Genrich Schuler, okay, since 1946 in the former Soviet Union, USSR. So although this method has been long used, but it actually reaches to the public, okay, once the republic collapsed. So once the republic collapsed, okay, the collapse of the USSR, okay, then so many of the TRIZ practitioners have the opportunity to go abroad and disseminate the knowledge. So TRIZ is based on the study of patterns of problem and solution. So TRIZ provide repeatability, predictability, and reliability due to its structure and algorithmic approach. So it is an algorithm of problem solving. What means by algorithm is that it proposes step-by-step or standard operating procedure for us to solve a problem, which is highly beneficial, okay, to those without a proper, to those who wanted to solve problem, okay, but doesn't know the way to do so, okay, systematically. It can be applied either in individual setting or a team setting to solve problem. So the method started by analyzing data from patterns. So, but Arshula started by examining patterns when he was working in the Russian patent office. So while analyzing all the patterns, he identified that over the 200,000 patterns, there are 40,000 patterns that are considered an innovative pattern. Okay. And from that innovative pattern, okay, so what innovative patterns mean that the patterns that he discovered, okay, have some trade-off to solve. The solution have some trade-off to solve. So based on the 40,000 patterns, they are later mined, okay, or analyzed in and conclude in and concluded this section. One, what he discovered was problem and solutions, okay, are repeated across industries and science. So within the 40,000 patterns, some of the pattern uses the same principle of problem solving, okay, but to solve different setting of problem. Okay. One principle of solution can be has been used to apply to solve problem in medicine. The same principle is used to solve problem in engineering. The same principle of solution is used to problem in science. So same solutions are repeated across different type of problems. And he later obtained a repetitive 40 type of inventive principles that are used to solve the 40,000 inventive problems. So he also discovered that there are patterns of technical evolution repeated across industries and science. Okay, through this means, we found that technological solutions tend to advance and follow a certain type of trends. Okay, and by knowing that trends, it helps to predict what the future will be coming for the technological solution. Okay. And third is innovation used in scientific effect outside the field from where the original problem was found. Okay. So this means that scientific effect can be used to solve problems in a unique way. Right. TRIZ hypothesis is very simple. Okay. Somewhere, someone has already solved this problem or one very similar to it. And based on this hypothesis, what TRIZ would like to emphasize is that creativity is now finding that solution and adopting it to this particular problem. Okay, we can have a further look how this hypothesis can be further explained. Okay. Problem and solutions are repeated across industries and science. One example, how do you remove the core from a bell pepper? So we would like to remove the core of the bell pepper. Okay. Is there any solution to this problem? Okay. One solution is based on the principle of raising pressure slowly and then suddenly reduce it. So the processed pepper is kept into a container, air is pumped into the container, and then compressed air is suddenly released. The change of pressure cause core to be separated from the bell pepper. So this principle of solution to remove the core from the pepper was patented in 1945. Later on, in 1950, the same principle of solution was also applied on to remove the shell from a cedar nut. So we like to have the inside of the nuts. How do we solve the problem? Okay. So using the same principle of operation, slowly raising the pressure and suddenly reduce it. Okay, the principle was able to break the nuts and separate the shell from the nuts. So this pattern, using similar concept or principle of solution, was patented in 1950. So now we can see a principle of operation but applied in two different problems. One is for the bell pepper in 1945, followed by the cedar nuts problem in 1950. And 27 years later, the same principle of solution was also applied to break diamond into smaller pieces. Yeah. So this is what TRIZ has hypothesized, that somewhere, someone has already solved the problem or most nearly same to the problem, using the same principle of solution. So what we look for creativity now is also on how to apply the same principle of solution to solve different type of problems. So this is the pattern. Based on the existing literature, TRIZ has now been widely used by many industrial players to solve various type of problems, okay, owing to the effectiveness of the problem. Among the heavily uh, most industrial players, okay, one of the industrial players highly involved in this method to solve and to create innovation in their works is Samsung. Okay, right. These are some of the statements highlighting the success of TRIZ. So, in specific, what is TRIZ? So, actually, TRIZ is a problem-solving method. Okay, it's a structured and systematic problem-solving method that deviates from the traditional trial and error problem-solving approach. What is trying to achieve is to increase the efficiency and speed of innovation, apart from lifting the creativity of the people. So in trial and error problem solving method, in many being does not the solution developed to solve the problem does not coincide at all. So it is a waste of resources in terms of time, manpower, etc. There are many structured ways that have been developed, okay, to channel all the effort towards the solution more effectively. So I think many of you has also been are aware of several of the other type of structured ways in problem solving, such as brainstorming, morphological approach, etc. So TRIZ is an alternative to the structured ways in problem solving. TRIZ also try to address to break the limitation of usual problem solving method, such as psychological inertia. Okay, it hinders us to think creatively. Lack of knowledge in the subject matter that we would like to solve. Wrong objective or goal. Okay, we also tends to agree on conflict, okay, or contradiction or trade-off at the end of the problem-solving process, which is actually not solving the problem as a whole. So what TRIZ does is it tries to solve the problem holistically. And other final limitation is most practitioners do not know how to define the actual root cause. So without having to know the actual root cause, then the actual or the effective solution to solve the problem could not be found. How does this work? So since it is a systematic manner, okay, it's systematic process, not an intuitive process. Okay, so how this works is that first it works on the specific problem, converting that specific or complex problem into a more simplified or understandable. From that simplified problem, we can have a general solution, a general problem, from general problem into a general solution, and later on work and based on the general solution, work on the specific solution, and eventually solve the specific problem. Okay. Later on, there will be interesting cases how this can be applied. So this is how we solve problem in general. So a complex problem, then we change into a more generalized problem, making it more generalized. From that generalized problem, we use some sort of tools or solving operators, okay, to find a general solution. And from that general solution, once we key in all the specific elements, we are able to later convert the complex or the complex problem into a complex, we can find the complex solution for the complex problem. This also works on the same way, okay? Specific problem, and we would like to have a specific solution. Okay, there's a barrier into it. So we first simplify, generalize the problem, determine the general solution, and later on work out the specific solution. Okay, so there are many tools can be used for problem solving in TRIZ, but for today, later on, we will share this one model of solution using TRIZ. So some basic concept of TRIZ, okay. First is agility, contradiction, resources, and system approach. Okay, into you in terms of system approach and agility. So how the TRIZ concept works. System approach. So basically what system approach means is it organize, okay, the structure of total solution into or break the system into individual elements. Okay, right. So for example, so we have the solar system. Our solar system comprised of smaller elements such as the planets, okay, and the system itself is part of the another multi system. Okay, our body itself, so our body can be divided into more into individual components. Okay, increase. Okay, the component, the system are divided into system components. Okay, or the subcomponent, the super system component, whatever interacts with the product and the product itself. Okay. So for example, we have a pen. Okay, the component of a pen can be the ink, the case, the string, etc. Okay, the product itself is the pen. The super system that interacts with the pen would be the book, ourselves, the hand, the humidity, the air, etc. And this is based on the main useful function of a system. Functionality increase, so it emphasizes on function. So all problems can be solved by determining the function of the product or the main function which reflect the problem. People buy function, not functionality, or functionality products. And by understanding function and functionality at the most basic level, is the key to the success application of TRIZ. So what TRIZ interestingly emphasize of in is solution change, but functions stay the same, remains, and knowledge classification by function allow ready access to other solutions. Okay, so so it looks in a different way to solve problem. Rather than we solve the product, we can also solve the problem by looking at the product function. And another interesting concept of TRIZ is ideality. The problem can be solved, and by having the improvement in mind, we can push the solution into an ideal mode. Okay. So, example of ideal, the mathematical derivation of ideality. So, for example, we to increase the value of the product, what we can do is increase all the useful functionality and in the same time reduce all the cost and harmful effects. So by this way, we can push to the highest functionality level as possible without any harmful or negative sides. So as the value increase, okay, we can achieve the ideality in the solution. On how to make a product more ideal is to increase the amount of function, transfer as many function as possible to the working component, which produce the system final action, to transfer some function from the system to a super system or to the outside of the environment, and finally to use internal and external resources that already exist and available. So we can reduce the cost and reduce the harmful effect, and in the same time increase full function, okay, for any product or the solution that we have proposed. Okay, so I think that's all from me, okay, for the introduction. Dr. Adrinata will continue the presentation for the TRIZ solution model. All right, thank you very much.
Maybe we invite Dr. Adrinata for next session after end of talk from Dr. Adrinata. We will have a Q&A session after that. Okay.
Thank you very much, Dr. Rizwan and also Dr. Rodi. So today I will explain about the introduction of TRIZ, especially in engineering contradiction, which covers the engineering contradiction itself, and then the 39 parameters, and final is the inventive principle. So we have 40 inventive principles. So from the explanation, and Dr. Rizwan has told that we are actually giving an introduction of the TRIZ about the left one. Okay, there are one of the TRIZ tools that we commonly use, which is engineering contradiction matrix, specific inventive principles. So there are tools and application that we need to know to at least generate an ideas and then innovate some things. So there are a lot of TRIZ tools, and there are a lot of application from the TRIZ tools. As you can see in the slide, we have a problem solving, define problem, and root cause identification. So this is the list in the slide is the tools that are available in TRIZ, and then we are actually before we know how to use the engineering contradiction, actually we need to know the function analysis. But for the time being, this webinar will be the introduction for engineering contradiction and how do you want to solve the contradiction itself. In the list is the inventive principles, and then we have function-oriented search, trimming, 9 windows, and there are a lot of tools that are available in the TRIZ method. TRIZ tool, engineering contradiction. What is engineering contradiction? A contradict, small and big, short and tall. So there is a contradict. What is engineering contradiction? What are system parameters? So I think most of you guys are engineers, so we have used the parameters like length, weight, speed, velocity. What are inventive principles? This is what we want to look at, especially there are 40 inventive principles that could generate some ideas to solve our engineering problems. How to use contradiction matrix, and there are contradiction matrix from the 39 parameters that will lead you to use each inventive principles. And we will look at 2 case studies that we have done before. Okay. What is contradiction? An improvement in one characteristic of a system results in the degradation of another characteristics. As one characteristic gets better, another characteristic gets worse. So one character will improve and the other will worsen. If I make the gas stove burn hotter, so you switch on the burner with higher stove burn, okay, then the kettle of water boils faster, but the gas consumption is higher. So they are contradict with the parameters. If I make the leaf larger, then it can carry more loads, but it becomes heavier. So the leaf will get heavy when we make a bigger leaf. If I increase speed of the car, then I can reach destination in shorter time. So faster, shorter time, but fuel consumption will be higher. Traditionally, the problem is addressed by compromise, sacrifice, or trade-off. So in case of our speed of car, so you need to drive at 100 kilometer per hour, sacrifice your time, because you need to get high consumption of fuel, okay, something like that. So you need something sacrifice or trade off. Okay, what is engineering contradiction? An engineering contradiction is a situation in which an attempt to improve one parameter leads to worse the pair. Okay, so there are 2 parameters that will improve one parameter and worse the other one. It can be reflected in a positive and negative interaction between 2 or more components. So there are interaction between subject, object, and components. In TRIZ, the lines, the arrow from subject to object, let's say action 1, action 2, action 4, gives meaning. Okay, so for action 1, it is a normal interaction. Action number 3 with the dash line or dotted line, it is insufficient, not sufficient for the subject to the object. So let's say we hold our cup with insufficient force. So we will put it as a dash or dotted line. And then wavy line with red color, it is harmful. So we hold our cup that have a hot water, so it is harmful. Okay, and the other way around, action 1, 2, 3, and there are high weight on the arrow of action 5. It is excessive, extra of force or extra of effort to doing that kind of action. Okay. To solve the engineering contradiction, you need to identify, understand, and resolve the engineering contradiction within a system. It's a powerful way to improve the system. So engineering contradiction is a way to improve, and it is very powerful. It is possible to eliminate the engineering contradiction rather than looking for trade-offs. We need something very good for the result. And for the engineering contradiction, we use the terms if, then, but. Use if for the manipulative variable, and then a responding variable for the improve of parameters, and then but responding variables number 2. What happened to the worsened parameters? If table legs are changed from plastic to metal, then the strength of the table improves, but the weight of the table worsens. So there are contradiction of the strength of table and also the weight of table, while the variables is diameter of table legs. The hypothesis is a contradiction if then but. So we got something, if we increase the diameter of the table legs, then the strength of the table improve. Okay, but the weight of the table worsen. So it got more weight if we increase the diameter. Hypothesis can be separated into two. The first one is for the improvement, and the second one is for the worsenings. If we increase the diameter of the table legs, then the strength of the table improves. So if we reduce the diameter of the table legs, then the strength of the table worsens. So there are contradict of increase and reducing the diameter. Okay, so we need to validate that the hypothesis is true to identify actual root cause. So the first one is we need our engineering contradiction using our if, then, but. Okay, so if variables, then parameters, but parameters improve and worsen. The inventive principles are simple ways to resolve engineering contradictions. The application of the principles does not require any special knowledge. Adults as well as children can use them easily. So this is about the inventive principles. There are two methods to apply the inventive principles. There are 40 inventive principles. It is rather you are using contradiction matrix. Okay, we have the contradiction matrix. And then we can get familiarized with all the 40 inventive principles. It is actually in your head. When you are master in the 40 inventive principles, I think that is enough for you to solve an engineering problems to get at least an idea, okay, to solve our engineering contradiction. The contradiction matrix was designed to formalize and facilitate the usage of the inventive principles. It was one of the first outcomes of the work of Australia. So the contradiction matrix is the results of Jerry Australia in this TRIZ. He abstracted and classified the inventive principles and also identified system parameters that can describe all the different soft contradiction. So the keyword here is engineering contradiction, which is if, then, but. In our engineering contradiction, we have parameters, which is the improved parameters and also the worsens parameters. And then from that parameters, we check using our contradiction matrix, and then we can have an idea of our inventive principles. The system parameters laid out 39 times 39 matrix. So our contradiction matrix is from the improve and worsen characteristics with the 39 parameters. And then we can find the solutions using the inventive principles as stated in the contradiction matrix. The system parameters 39 times 39, x-axis is the parameter that worsen, x is worse, y is improve. So I try to share the engineering contradiction matrix. Okay, so this is our contradiction matrix. So you can go to TRIZ 40, triz40.com. Okay, then you can choose the contradiction matrix here. So you can choose the matrix, contradiction matrix, and we will look at the inventive principles. So there are, as in the slide, we say that there are 39 parameters, 1 until 39 parameters. And for the y-axis, it is improving parameters. And for the x-axis is the worsening parameters. Okay, so this is our contradiction matrix, and there are, if you can see, there are numbers in the contradiction matrix. If I can make it bigger. Okay, so this is our contradiction matrix. Let's say we improve weight of moving object. So that is parameters in our if, then, but. So we want to, the improvement is moving weight of moving object, and the worsening factor is the length of moving object. Okay, so we can see that it is number 15, 8, 29, and 34. And this is the 40 inventive principle that we will look after this one by one. So number 15 is dynamics, number 8 is anti-weight, number 29 is pneumatics, number 34 is discarding and recovering. Okay, so we go back to our slides. So this is the contradiction matrix, which shown that in contradiction matrix, we have our 39 parameters, which is improve and worsen, and also our inventive principles inside the box, inside the matrix of our 39 parameters. So it is like this. So for the Y, we have improving feature, and X is worsening feature. And we can see that there are numbers which is 1, 2, 3, and it is the same, okay, from x-axis and y-axis. So it's the same parameters. What is parameter? So for engineer, I hope that you easily understand that what is the parameter. Which is parameter is defined as any factor that defines a system and determines or limits its performance. Like this snail. Yes, I'm from Egypt. How did you know? Guess. So the pyramid of the snails tells that is from Egypt. Parameter typically describes the characteristics of a system. A parameter is property or attribute given to describe a system. So parameter, length, weight, speed, Okay, this is our 39 parameters, which is this is in the list of our contradiction matrix, which is weight of moving object, weight of stationary, length. So you need to define what parameters. You have your contradiction matrix. Okay, at the first place, you have your contradiction matrix, if, then, but. So from improved parameters, you will match with the 39 parameters that we have, that listed in the 39 system parameters. So you will use one for the improving characteristics, and number two is for the worsening characteristic. It is the same parameters in the list, okay? But for the improve and worsening parameters, it should be different. You cannot define as you want to improve the speed, and also you want to the speed is worsening. Okay, if you improve the speed worsen, so you cannot do that, so there are no contradiction. Okay, and then there are 39 parameters, and what is inventive principles? This is what Ashula have done for the first of TRIZ method, and that is why engineering contradiction, 39 parameters, and 40 inventive principles is teach in TRIZ level 1 for a practitioner and also for instructor. Inventive principle is a basic generalized rule that is accepted as facts, works in exactly the same way consistently, and usually followed as a basis of reasoning or explanation of the invention. So from out of the 40,000 innovation patents, Ashula have grouped that invention into 40 inventive principles. So it is the same idea as Dr. Rizwan said, someone, somewhere, somebody has done it. Okay, so it is the replication of patents to innovate something. So patents which had contradiction, and from this he developed set of 40 inventive principles. Let's review the 40 inventive principles. So we have 40 inventive principles to review. This is the list of our inventive principle. As I show you the contradiction matrix. Contradiction matrix includes of 39 improving parameters on y-axis and 39 parameters of worsening factors in x-axis. So in the box, in the matrix, is this one, 40 inventive principles. So let's say we have looked at the number 15, number 8, before this 15 is dynamization, number 8 is anti-weight. So this is the inventive principle that will give some ideas to us to innovate and solve our engineering problems. Okay, so there are 3 steps that we need to use. The first one is engineering contradiction, and then from the engineering contradiction, we got 39 parameters. Okay, 39 parameters is this one. Parameters, length, time, weight. So this is parameters. The second one, and the third one is the inventive principle that we need to use. Segmentation. Okay, this is number 1, segmentation. So we will look at the all of the 40 inventive principles that maybe give us some ideas on solving what engineering problems in our head right now. Okay, so there are a segmentation. First one is segmentation. Segmentation, divide an object into independent parts. Okay, so divide into independent parts. It's like furniture on our IKEA. So make an object easy to disassemble. So it is easy to disassemble. Increase the degree of fragmentation or segmentation. So the degree of segmentation we improve, we increase. Okay. And then transition to micro level. Examples, concept of modular furniture where the components of the furniture are disassembled at the point of purchase and during transport. So when we reach home, then we open the box and we assemble our furniture. This is like an IKEA product. Break into small teams. This is for human resource or management. Break into small teams. Virtual office, modular office, divide a difficult problem into smaller segments for better focus. So this is market segmentations. Distributed computing, client server computing. So this is in computer engineering. Segment like files, IP packets for telecommunications. Number 2, taking out. Separate an interfering part of or property from an object, or single out the only necessary part or property of an object. Taking out, which is not necessary, you need to take it out. So this is some idea. If you have engineering problems, and then it gives us the inventive principles, this one, taking out. So we need to think and find that something that we can take out from our current engineering problems. So, examples, move a person to an area where the person's strengths can be fully utilized. Identify the extreme behaviors in the group. Just-in-time inventory management. So this is in the management. The air conditioning compressor, which is noisy and hot, is moved to outside of the building. So taking out from inside to the outside. Remove all access, remove unwanted emails in information technology. Okay. Number 3, local quality. Local. So each of them is local, and we give them each specific job task. Change an object structure from uniform to non-uniform. Change an external environment or external influence from uniform to non-uniform. Make each part of an object function in condition most suitable for its operation. Make each part of an object fulfill a different and useful function. Okay. Examples, we have a vacuum cleaner. We have a vacuum cleaner which has a part which suck up the dust. The first part is suck up the dust. And then we have filter. So there are filter to filter the dust. And then we have storage of the dust. So we have given each of them job, their specific job. So local quality. Create recreational rooms, pantry area in the office, skill or personality matching in project, teams, flexi, work hours, kids area. So we have divided our teachers, our innovators, our management, so in different area with their ability. Different quality of printing for this is in printer, draft, normal, presentation. So each of them have their specific. Add special effects, sound, graphics. This is for graphics users. Principle number 4, asymmetry. Asymmetry we can use for symmetric or non-symmetric. So we have changed the shape of an object from symmetrical to asymmetrical. So we need to think something that not symmetry. If an object is already asymmetrical, increase its degree of symmetry. So you need to increase. Merging. Principle number 5. So this is inventive principle number 5. Bring together or merge similar object, assemble, identical, similar parts to perform parallel operations. Merging also make operation contiguous or parallel, bring them together in time. So merge. So combine, this is for management, combine team members, for rowers in a boat work together to move the boat faster, so forth, and so on. Universality, universal, make a part or object perform multiple functions, eliminate the need for other parts. You have your scissors, you have your knife in one of your components. Okay, there are system of knife, of scissors, rulers. Okay, so universal, so it can be used. Handphone, you have your GPS, you have your camera, you can call, so everything in one components, one parts, one-stop shop which is able to provide all the necessary support. So this is universality. Okay, multifunction. Nested doll. Place one object inside another. Place each other in turn inside the other. Make one part pass through a cavity in another. So this is like antenna of a car. It is too long, and then you can make it nested doll. Nested doll is put the smaller one into the bigger one, and then the smallest one into the smaller. So that is a nested doll. So it is like antenna of the car, tripod, camera, and everything. Nested doll. Anti-wake. Okay, so for anti-wake, to compensate for the weight of an object, merge it with other objects that provide lift to compensate for the weight of an object, make it interact with the environment, use aerodynamic, hydrodynamic, buoyancy, and other forces. So anti-wake, it's something that's floating. Preliminary anti-action. If it will be necessary to do an action with both harmful and useful, you have harmful and useful effects. This action should be replaced with anti-action to control harmful effects. Create beforehand stresses in an object that will oppose known undesirable working stress later on. So, preliminary anti-action, perform risk assessment to determine risk level and corrective action, enable screensaver to protect user when away. So preliminary anti-action. Principle number 10, inventive principle number 10 is preliminary action. Perform the required change of an object, either fully or partially, before it is needed. Prearrange objects such that they can come into action from the most convenient place and without losing time for their delivery. So example is a preliminary action of you marinate your food, provide training, pre-planning, compressed backup. Beforehand cushioning. Prepare emergency means beforehand to compensate for the relatively low reliability of an object. Beforehand cushioning, backup parachute is used to compensate for the low reliability of the main parachute. So we have backup. And airbag will deploy before the crash. Okay, so backup parachute, backup computer data. So beforehand cushioning, preventive. Okay, in a principle number 12, equipotentiality, equal potential. Okay, so in a potential field, limit position changes. Example, change operating condition to eliminate the need to raise or lower objects in gravity fields. Equal technical and management skill level. So equal with the potential. Use high-speed memory for high-speed processor. So use high resolution graphics acceleration resolution monitor. So this is something about what we hear about a computer, which is a bottleneck. You need to use your processor with the equal of your graphic cards. Okay, so you have optimum of results. Principle 13, the other way around. Invert the action to solve the problems. Instead, you cool the object, you hit it. So this is something ideas that to solve our engineering problems. Make movable parts or the external environment. So this is the other way around, opposite from what you have in your hand. Turn the object or process upside down. So it is contra. Principle number 14, curvature. Instead of using rectilinear parts, surfaces, or forms, use curvilinear ones. Move from flat surfaces to spherical ones, from parts shaped as a cube to ball-shaped structure. So you need a rounded curve, like rollers, balls, spirals, domes that have a curve. Go from linear to rotary motion, use centrifugal forces. So this is in principle of curvature. Dynamization, movable, flexible. Allow or design the characteristic of an object, external environment, or process to change to be optimal, or to find an optimal operating. Can one solution apply multiple inventive principles simultaneously? Okay, divide an object into parts capable of movement relative to each other. If an object or process is rigid or inflexible, make it movable or adaptive. So I change it to dynamics. Okay, dynamization. Partial or excessive action. If 100% of an object is hard to achieve using a given solution method, then by using slightly less or slightly more, okay, partial or excessive, slightly less or slightly more of the same method, the problem may be considerable easier to solve. So there are something that we need to use partial or excessive action beforehand. Okay, in screen printing, excessive ink is applied on stencil, and a squeegee is used to wipe off the excess ink. So, like in the slide, we put the ink, and then the squeegee wipe using the wipe to the ink, excess ink, and utilize current resources and develop them extensively. Over communicate roles, responsibilities, scope. If system takes long time to reboot, choose hibernate. Okay, and then another dimension. Another dimension, principle number 17, move an object in 2 or 3 dimensional space. Use a multi-story arrangement of objects instead of a single story arrangement. So you need to think the other dimension. Tilt or reorient the object on it. So another dimension you need to give extra. CD changer cassette with many stack CDs. 360-degree feedbacks. So this one is for the another dimension. Mechanical vibrations. Mechanical vibration cause an object to oscillate or vibrate, increase its frequency. Use an object's resonant frequency, so resonance. Use piezoelectric, use combined ultrasonics. Examples is to break our gallstones into smaller pieces. We use ultrasonic, which is vibrations, ultrasonics, okay? resonance. Immediate feedback to manager. Throw out assumptions every 3 weeks for startup company. Cursor control with vibrate and shake. Okay. Periodic action. Instead of continuous action, use periodic or pulsating actions. If an action is already periodic, change it to magnitude period. This is using the frequency and pauses between impulse. Okay, to perform a different action. So need to start and stop. Continuity of useful action. Number 20. Carry on work continuously. Make all parts of an object work at full load all the time. So full swing. Eliminate all idle or intermittent actions or work. So this is opposite with the previous one. We need to do it in impulse. And this one is suited to full swing, 24 hours, non-stop. Principle 21, skipping. Conduct a process or certain stages, destructible, harmful, or hazardous operation at high speed. Examples to avoid hitting gum tissues, as in the picture, can use a high-speed dentist drill. So this is a high-speed. Skip unwanted steps. Okay, fast delete, shortcut, hotkeys. So skipping. Skip. Principle 22, blessing in disguise. Use harmful factors, particularly harmful effects of the environment or surroundings, positive effects, eliminate the primary harmful action by adding it to another harmful action. Okay, so keep, as an example, keep traffic out of city through cheap park and ride and expensive downtown parking. Restrict supply of goods to create scarcity value. So use harmful factors. If you have harmful, add another harmful factors to solve the problems. Feedback. Introduce feedback, referring back, cross-checking. So feedback to improve process of action. If feedback is already used, change its magnitude or influence. So the magnitude periodic, monthly, annually, so on and so forth. So that is a feedback. Principle 24, intermediary. Something in between. Use an intermediary carrier, article, or intermediary process. Something in between. Merge one object temporarily with another. So you merge. It is something like merging. So you merge with another, with the process or product. So it can be easily removed. Okay. Recycle bin, keeping deleted files, buffering to store video data temporarily before display. So this is the examples. Principle 25, self-service. So self-service, like laundry. So now you have your washing machine and you have your dryer, okay, which is a 14 kilogram dryer. So it is a self-service. Make an object serve itself by performing auxiliary helpful functions. Use waste resources, energy, or substance. So there are ideas come for the laundry services. So you go to the laundry room and then you make it, you serve yourself to clean your garments. Copying. Okay, so a simplified and inexpensive copy should be used in place of a fragile original or an object that is inconvenient to operate. Replace an object or system of object with an optical image. The image can be reduced or enlarged. Okay. So copying is copy. Listen to an audio CD instead of physically attending a conference. Lead by example, video conferencing instead of physical travel. So what we are doing right now, okay, copying from face to face into a visual, okay. Cheap, short-living objects. Replace an expensive object with a multiple of inexpensive objects. So cheap, short-living object. Mechanic substitutions. Replace a mechanical with a sensor. So from mechanical approach to sensor approach. So from drive by the mechanical gear, you can drive it by your magnetic field. So from mechanical to sensor. Use electromagnetic to interact with the objects. Change from static to movable fields. So multimedia presentations, flexible head count, voice recognition. So this is more or less for the information technology. Pneumatics and hydraulics. Okay, so they suggest the inventive principle suggests in your problem is to use pneumatics and hydraulics. So use gas and liquid parts of an object instead of solid parts. So there are suggestions to you to solve your engineering problems. Use pneumatics and hydraulics. Okay, 29. Principle 30. Flexible shells and thin films. Use flexible shells and thin films instead of three-dimensional structures. Isolate the objects from the external environment using flexible shells and thin films. Okay, so laminated safety glass for car windshields, plastic bags, plastic wraps, fire compression to reduce this space, fire compression. Okay, so this is inventive principle number 30. Principle number 31, inventive principle number 31, porous materials. From solid, you can make it porous or use supplementary porous elements. Okay, if an object is already porous, fill pores in advance with some substance. So add some substance. Since a solid brick is heavy, introduce holes in the brick to reduce its weight while maintaining its strength. So porous, we have holes for our bricks. Color change. This is very nice. Change the color of an object or its external environment. Change the transparency of an object or its external environment. In order to improve observability of things that are difficult to see, use colored additives or luminescent elements. So you have a mark. If it is hot, it will change to red color. Okay. Then if it is cold, it is in blue color. So color change of your mark. In order to ensure that Ziploc bags are properly sealed, have one side in blue color and another in yellow color. When the bags are zipped properly, it is indicated by green color. So color changes. Principal homogeneity. Make objects interact with a given object of the same material or material with identical properties. So homogeneous. With the same material, same product, same object. Make a diamond cutting tool out of diamond. So the same product. Use sandblasting to create an imprint on glass since both materials are made of silicon. So homogeneity. Okay, 4 o'clock. Discarding and recovering. Make portions of an object that have fulfilled their functions go away. So discard and recover. Discard by dissolve or evaporate. Conversely, restore consumable parts of an object directly in operations. So we have dissolved our capsule for our medicine. Auto deletion, this is in computer engineering. Principle 35, parameter changes. Change an object's physical state. So parameter changes from gas, liquid or solid. Change the concentration, change the degree of flexibility from the solid one to flexible, change the temperature, the pressure. So this is under parameter changes. So the parameter changes is what Dr. Rizwan explained for the air pressure. You add air pressure and then suddenly remove. So parameter changes to get your bell peppers. Phase transition. Use phenomena occurring during phase transition. Refrigerating, hot radiator. So this is a phase transition. Thermal expansion. Use thermal expansion or contraction of materials. If thermal expansion is being used, use multiple materials with different coefficients of thermal expansions. In our iron, okay. So thermal expansion with two different materials. A strong oxidants. Replace our common air with oxygen, enrich air. Replace enrich air with pure oxygen. So this is about the oxygen. Okay, add some oxygen. Inert atmosphere. So this is number 39. Replace a normal environment with an inert one. Add neutral parts or inert additives to an object. So inert atmosphere. This is gas. Okay. And principle 40, composite materials. Change from uniform to composite materials. So this is about 40 inventive principles, and we have gone through all the 40 inventive principles, and this is an idea of the principles in TRIZ to solve our engineering problems. At least we have an idea. So there are questions from Dr. Rizwan. Can one solution apply multiple inventive principles simultaneously? One solution apply multiple inventive principles. So something like merging, like I said in the previous slides. Okay, so we have data. Okay, we have data from TRIZ journals where they are using one principle, two principles, three principles, four principles. So this is out of our 40 inventive principles. So to let you know that if you have more than one principles, the level inventions is higher. Okay, so levels of invention, and then this is what I always keep on telling, that there are three things that three simple steps, which is the first one is define the improving and worsening parameters from if then but analysis. You will need to fit the problem parameters. So you need to find the parameters with the characteristic of if then but that you have, right? And then you need to identify the inventive principles from the contradiction matrix, and you need to generate solutions. So if more solution needed, review through the remaining 40 inventive principles. There are two methods that I have explained. The method one is you use the contradiction matrix, And then method number 2 is you go through the 40 inventive principles. Okay, and then apply the inventive principles to solve the contradiction. When an offered principle is acceptable but generates a secondary problem, do not automatically reject. Find ways to solve the secondary problem. Okay, now I will share our experience on solve some problems. This is our case study. The first one is The first one is about our charger cable. Okay, we need a very long charger cable for us for easy for our easiness. And then if the cable is long, then it can be used to connect and charge electronic device to the charging part over longer range during use, but cause problem of dangling and unorganized cable after not in use. Figure is the current products in the market. Okay, you have the magnetically attached charger cable. So when you need it short, you can make it short, and when it is you need it longer cable, you can detach it from the magnetic and use for longer area. And then similarly, the contradiction phrase could also be formulated in below statement. The cable should be long while in use to connect and charge electronic device to the charging port over longer range, and the cable should be short when it not in use to avoid dangling and unorganized. So if, then, but. Okay, so we are using if, then, but. So from that, okay, so from that we have our improving parameters. Improving parameters is length of stationary object, and worsening parameters is adaptability or versatility. So this is from the 39 parameters. Okay, so this is the current engineering problems. This is the simplified problems, and this is the general solution from contradiction matrix. Okay, so from the contradiction matrix, improve is number 4, and then worsen is number 35. Okay, 4 and 5. Stop sharing this. We have 3 and 5. Okay, so 3, length of moving object 3, and 35. So we need to find number 35. Sorry. So this is the worsening factors of number 35. And what it is? 135. Okay. So this is the contradiction matrix and generalized solution. Okay. So so from the generalized solution, we have the inventive principles of number 1, segmentation, number 35, parameter change. So you have an idea and you need to think of something that segmentation and something that can change the parameter. Okay, so something like flexible, but our cable is flexible. It is something like okay, parameter change. It is available in the market, which is from wired. Okay, so from wired you change it to wireless. Okay, wireless charging. So that is from parameter change, and it is available in the market. But we as problems for our case study, we need the cable. We still need the cable to remove the dangling. Okay. So this is the results for intermediary that we have used. Okay, and then this is the designs of our charger cables and also our charger plug. Okay, so this is the concepts of yo-yo. This one is concept of donut. Okay, and this is the designer. Okay, this is the name of the designer, Dr. Shaibuddin. Okay, so we have, this is another things which is accessories that we can attach and detach, and we can bring it with us. So we have additional accessories that attach to the charger, and we can roll our cable to our charger. Okay, next. Case study number 2. There are spill water. If you can have an experience, when we use this water dispenser tap, there will be a water spill at on our table or on the floor. Okay, so water spillage. If the nozzle pointing upwards, then it will prevent water spill. Okay, so we need to turn it around, but reduce user convenience. How to take our water? So they are very difficult. Ease of use to the user as well as reducing water flow process. So we have the parameters. We have if then but is prevent to improve the water spill, prevent water spill, and then to reduce user ease of use. This is the contradiction, engineering contradiction. And then we have a quantity of substance. So these problems, this specific problem, we define it to our simplified problems using our 39 parameters. So we have 39 parameters. So what is this? This is number 23 versus 33. So 23 is in your y direction, y axis, improved parameters, and then worst parameters is in your x axis. Saya tak nampak kalau ada soalan keluar. Ada. Okay. So for the solution, we need to find in the contradiction matrix on the 23 versus 33. Okay, so from the contradiction matrix, we get, ta-da! So number 23, okay, we have number 23, quantity of substance to improve, and its operation, which is worsen parameters. So we have decided to turn our nozzle upwards. Okay, so this is the inventive principle listed in the contradiction matrix. Color changes, mechanic substitution, taking out intermediary. So we use mechanics taking out. Okay, so taking out, if you can see from the water tap, inside water tap, they have seat, they have something like rubber. Okay, so inside the water dispenser tap. Okay, and then we take it out, and then we design a new water tap. So this one is when we put it down. Okay, the nozzle face down, then the water can be put in the cup, and then if not, we put it back to upwards. Okay, to open, to dispense, and to close the water, just using our hand to rotate the nozzles. So what I have explained and what we have discussed is the TRIZ model on engineering contradiction, 39 parameters, and 40 inventive principles. So there are 40% of around 40 to 50% of our TRIZ level 1. Okay, so that is the knowledge in TRIZ level 1. So what we have done how to define the problem, and we know how to define how to identify our contradiction. So which contradict. Then we use if then but to get our 39 system parameters. Okay, and then we use our contradiction matrix to see what inventive principles that we have we can use. Okay, so this is for general solution, and then we need to specify the generate specific solutions. So this is what TRIZ has teach us as a TRIZ practitioner and also TRIZ instructor. Okay, so this is the whole process, okay, in this webinar. So at least you have known 39 parameters, engineering contradiction, to convert it to 39 parameters and then find the inventive principles. Okay, and this is just to show the level of TRIZ, okay, that available, okay, from zero knowledge and then going to for 2 days class level 1. After that, you can be a TRIZ practitioner for level 1. And then you go for TRIZ level practitioner, TRIZ level 2, and then you can be the TRIZ practitioner for level 2, and then you can go for level 1 instructor. Okay, and then from a level 2 practitioner with level 1 instructor, you can go to level 3, which is 10 days class divided by three different times, 3 days, 3 days, and 4 days. Okay, so this is 10 days of level 3, and you will be learn about RIZ. Level 3 TRIZ practitioner, and then you can get your level 3 2 instructor. Okay, so what you need to pay. Okay, first level TRIZ level 1. Okay, level 2 TRIZ level 2, and then it is different with TRIZ level 1 instructor. So the blue color and red color is the money that you need to spend. Okay, this is the 25 tools that are available in TRIZ. So we have discussed about number 4, 5, and 6 for engineering contradiction matrix, and also 40 inventive principles. This is 50%. Okay, so 50%. So 1, 2, 3 is the function analysis, CEC, cause and effect change. Okay, CEC analysis, and also trimming method. In level 2, will be learn about physical contradiction, substance field, 76 standard inventive solutions, S curve, and this is for level 3 for 10 days. Level 1, 2 days. Level 2, 2 days. Level 3, 10 days. Okay, I think that's all from me. And if you have any question, you can ask. Our TRIZ practitioner and so TRIZ instructor are available and can share with us if you have any question. That's all from my TRIZ UTeM. Members of my TRIZ UTeM, thank you very much. If you have any question, I can ask. Thank you.
Thank you, Dr. Adrinata. All right, ladies and gentlemen, now we come to Q&A. If there are any questions, so you can ask here or you can write in the chat box. Any question from the floor?
Dr. Wan, unmute.
Right, thank you.
Okay, no question. So maybe you can directly email to our practitioner, certified practitioner, instructor also, Dr. Muhammad Ramanso and Dr. Adrinata after this. So,
Dr.
so
Rudi,
we will,
attendance form, E form.
and don't forget to fill out the e-attendance. The link I have provided in the chat box. So you may fill the attendance and the e-certificate will be emailed later on. So I would like to say, and we would like to say thanks again to our presenter for the informative and interesting talk, and to all the audience for the active participation. So hopefully the presentation will be beneficial for everybody. So again, thanks for your attention. Assalamualaikum warahmatullah. We end with Tabligh Kifara and Surah Wal-Asr. Okay, see you next session.
Next webinar. Thank you, Dr. Rudi. Thank you, Dr. Rizwan.
Thank you to all.
Thank you to all for listening to us.